we have understood the basic mandatory data structures that are required from the example. Let us move one step ahead of defining a class and defining all the required data types and data structures. Well, so as we have seen, now we have a try node, and then what you have, Aadhaar number to store this particular Aadhaar number into the node, and the nodes, these nodes. And how many of such nodes? So we're declaring one variable, digits, called 10, and then the constructor, this dot t node is equal to initializing it for 10. So this gets spinned up whenever you declare, whenever you use an object, whenever you instantiate this class. And then this dot Aadhaar number is -1. So initially I'm storing -1 at every Aadhaar number to denote that it is empty. Then you assign null at every reference because there is none. To begin with, there is none. So therefore, you initialize, assign null at every reference and assign -1 at every Aadhaar number. So this is the class. And now, what are the other auxiliary variables that we require? As we have seen, we need the Aadhaar length of size 12 and another total number of Aadhaars, 6 in this example. It can go up to any number. And then you have a root node to keep track of the root node. So this is the handle for us all the time. This is the handle. While building, you will return this. After building, you return this. For printing, you need this. For searching, you need this. This is your starting handle. Right? So that I'm calling it as a root node. And now, as said, so this list we will be storing in Aadhaar list. And this two-dimensional array is to translate, to convert these lists into two-dimensional array. You remember, we were going digit by digit. That's the important part. So we are going digit by digit. And we are comparing, let's say if there are duplicates, 5, 5, we are comparing with this and this. So you need to hold this into a two-dimensional array to index them, to traverse to the specified index. So therefore, this two-dimensional array. This is the fundamental understanding. This is how you translate an algorithm, an example, into code. You understand what is that you are doing. You notice the data structures that you require. Every sentence that you say, converts it into a data structure or a logic. So this is now the complete need of data structures that we require in order to build tries.
Let us understand the code. Let us walk through the code so that you will be able to write one on your own. We have understood the examples, algorithm, data structures required, and the logic. Now, so looking at the code, it would be pretty easy for you to make sense out of this code. So what you have here is a VSD insert node that is responsible to build the try data structure, and then you are sending the root node and then row index and column index. This row index and column index are coming from the list of array. That helps us to keep track of each digit in the given Aadhaar number. And then so we took the index that we require where to insert, right? So where to insert in a try node, so you need that index. So therefore, you are extracting that two-dimensional array's row index, column index into a new index. And now, so you are checking if the root node itself, the very index that you require. So in this case, 5, right? Our example. So we started with 543210. So it is 5. So the index 5 in the root node, is it null? For the first time, it would be null. So if it is null for the first time, you instantiate a new try node to it and then add the Aadhaar number into that node as we have discussed. You remember? So very first digit that you get it, the first time your root node is empty, so go to that particular index and insert your Aadhaar number. So that is taken care. Now next time, second iteration, you are coming with a new Aadhaar number. Now you get the index. Index is again, in our example, it is again 54321. So you have 5. So is the 5 index node at the root node. Is it null? No, it is not null. So you get into else part. So what do? You have to preserve the existing Aadhaar number as we have discussed in the algorithm. So you preserve the existing Aadhaar from whatever you have at the index, and then you assign it to -1. So which means the Aadhaar number is empty there, but the reference is not empty there, right? So then you come here. So you now move the root node to the next one, right? So your root node was here. Now you have instantiated a new array at 5 in this example. So you move your root node to the next node so that you can continue the further process. And now, so existing Aadhaar array, you converting the existing Aadhaar into Aadhaar array. And then you are getting the index of the existing Aadhaar array. See, always we were comparing with the existing Aadhaar array digits. You remember? So every time we compare, okay, 5, 4, 5, 4. So how do you get that? So you get that because you are storing the existing Aadhaar array into, existing Aadhaar number into an array. So that's what here you are doing and fetching the index of the existing Aadhaar array. You will always have the access to new Aadhaar with the row index and column index which you have got, right? So therefore we have to deal with the existing one, that is here. The line number 85, 86 are the ones. Now you go ahead and instantiate at the next digit number at 4 in this example. So new try node. Now what you are doing? So you are moving the previous existing Aadhaar number into new node's found digit. So you insert that. Then again, this is the beauty, recursion. You recursively call the function to continue the same process at the new node. So you have the root node, and from the root node you have instantiated new node. So root node is now holding 5. Next you are coming here, you are at 4. So do the same process from the next digit onwards. Right? So this is how recursively you call this function and build the entire try data structure. So what are you passing here? So the same root node and the row index, you are increasing the column index because now you have to move by one digit in the given Aadhaar number. So therefore you increase the column index by 1 and then you recursively call it. That's the beauty of recursion. And understanding the algorithm data structures required, you build the tree, you build the try in few lines of code. Hope this helped you. For downloading this program, you can go to vsdevelopers.io and you can send your comments on YouTube as well. Thank you for watching. All the best.